Lymphatic vessels, they're kind of like dead ends instead of like a blood capillary bed that's more like a cul-de-sac. These dead ends, we can call them lymphatic capillaries, and they're interwoven with blood capillary beds, as you can see in this picture on the top right. Lymphatic vessels, they have sections to them that kind of go like this. And at each of these sections, they're anchored down to the tissue below them. And these anchoring filaments, they usually attach to extracellular collagen, things like that. When the tissue swells with fluid, the venule side of the capillary bed is unable to reabsorb all that fluid. And the anchoring filaments, they start to move away from each other because of that swelling, and they open up this capillary, lymphatic capillary. These intercellular clefts actually start to open up, and the excess fluid then drains into the lymphatic capillary. Much like the larger veins of the legs, lymphatic vessels, they also have valves, which are like infoldings even more of these epithelial cells, and these valves prevent the backflow of this lymph fluid. Fluids from lymphatic capillaries can enter into lymph nodes through many afferent vessels. However, there is only one efferent vessel through which things can leave. That efferent vessel is usually larger than each of the individual afferent vessels, but the efferent vessel in no way compares to the cumulative diameter of all of the afferent vessels. This setup causes a bottleneck of fluid, and it allows more of the B and T cells living in the lymph node to come into contact with the fluids and inspect any of them for pathogens. You may think of a hair when I say the word follicle, but the term follicle usually just refers to some spheroidal shaped structure of organized cells. In a lymph node, there are primary lymphoid follicles that are composed mostly of B cells trapped in reticular connective tissue. And then there are secondary lymphoid follicles containing mostly T cells and macrophages. And this secondary lymphoid follicle also has a germinal center containing stem cells, mostly lymphoid stem cells. We have seen MALT tissue or mucosa-associated lymphoid tissue in places like the tonsils, the appendix, and the Peyer's patches of the small intestine. MALT is like an unencapsulated lymph node. A proper lymph node has a much more organized structure that consists of follicles that house mostly B cells and other surrounding tissue in the lymph node that houses T cells and macrophages. The primary tissue within a lymph node is reticular connective tissue, which was a loose connective tissue along with areolar and adipose. Reticular connective tissue, as its name implies, has only reticular fibers in it, no collagen or elastin, and those reticular fibers form a network or a webbing that basically traps the lymphocytes in it. Much like a lymph node, as fluids flow through the mucosa-associated lymphoid tissue, the MALT tissue is able, just like a lymph node, to kind of look over all of those fluids and make sure that there aren't any pathogens in there.